All right, taking a look at activity 5. So this is a sine graph, and this represents a spring or a pendulum going back and forth, right? You've got plus x and minus x, which represent the maximum places of this points of displacement. So as the spring goes back and forth like this, right, it reaches a point of positive maximum positive displacement and maximum negative displacement. And so what you're seeing here is this is just a graphics showing that. So here are the graphs, the spring's at equilibrium, or the block, it slides out to positive x, and then of course, since the spring is now stretched to a maximum, is stretched out, it has a restoring force pulling back to the left, which then causes the block to start moving back to the left until it reaches negative x, which now the spring is compressed, and so it pushes the block back out, and you get this repeating simple harmonic motion. So this is what this graph's representing. And so it's just asking you, for this situation, label the points where the potential energy is 0, velocity is a maximum, where is all of the energy stored in the spring, and there's no kinetic energy. Okay, so that's what you're doing for this one. For 2, it's the same idea, except the only thing you don't have to do for this is 2b and 2c. So for 2b and 2c, don't worry about doing those. Everything else you should be able to calculate based on the information they gave you here. And remember, so like for example, we want to find the frequency. All right, to find the frequency, I know that period is 1 over frequency, right? So then I know frequency is 1 over period. Those two are interchangeable. So I can find the period of a spring block system, and then if I know the period, I do the inverse of that to find the frequency. Okay, and so remember, how do you find the period of a spring block system? 2 pi root m over k. Okay, you can also do this here. In fact, to find the period, they tell you right here it does 2 cycles and 1 second. So how long does it take to do 1 cycle, right? The period's half a second. So that's the period, and then from that you can get the frequency and work down through these using your season 11 concepts. Okay, and all you're doing here is they give you a mass that's on a spring that's going back and forth, and they say at different points fill in the potential, kinetic, and velocity for the situation. So let's imagine here this -1. This is where it's compressed to a maximum amount. So think about, is this moving at all when it's maximally compressed, right? No. So the velocity is 0 there, and if the velocity is 0, the kinetic energy is 0. So those two are 0. Now, since energy is conserved and total energy is never lost or gained, the potential energy is going to be equal to the total amount of energy this has. Well, to find the total amount of energy, we can simply do 1/2 kx squared, right? Remember that potential energy elastic is equal to 1/2 kx squared. So to find the potential energy for a spring, which is PES, PEE, are the same thing. This worksheet does it as potential energy of a spring. I often do it potential energy elastic, but you can think of that as PES as well. They give you the K value. You know at this point it's stretched 1 meter, so from there you can calculate the potential energy spring and work from there to fill in the rest of the table. And then all you're doing here is you're taking your numbers from here and you're graphing them down here, right? So when it's at -1, what's maybe do 3 different color dots, red, green, and blue, and then graph those on the graph. And then down here, you're doing it in terms of the period, right? Remember, if it starts here, goes out, that's t divided by 4. That's 1/4 of the time it takes to do 1 cycle. It slides back, that's half the time. Gets to here, that's 3/4, and this is 1 full period. So that's t, total t, right? And so that's how you can fill out this chart where it has you write it in terms of t, right? So here is t0, t 1/4, t 1/2 on the way back, t 3/4, and then t, just t. Okay, which is going to be right there on the graph. So that's how you do activity 5.